The Sleepy Hollows of Mercury, presented by Science at NASA. The words Sleepy Hollow have been steeped in mystery ever since the 19th century, when Washington Irving wrote about the meeting of Ichabod Crane and the Headless Horseman in a secluded European glen. Of course, that was fiction. On the planet Mercury, the hollows are real. Orbiting Mercury, NASA's Messenger spacecraft has just discovered strange hollows as steeped in mystery as the one Irving wrote about so many years ago. High-resolution images reveal thousands of peculiar depressions at a variety of longitudes and latitudes, ranging in size from 60 feet to more than a mile across and 60 to 120 feet deep. No one knows how they got there. The hollows of Mercury were a major surprise, says David Blewett, science team member from the Johns Hopkins University Applied Physics Laboratory. We've been thinking of Mercury as a relic, a place that's not changing much anymore, but the hollows appear to be much younger than the craters in which they are found, and that means Mercury's surface is still evolving in a surprising way. Mars Reconnaissance Orbiter spotted similar depressions in the carbon dioxide ice at Mars' south pole, giving that surface a Swiss cheese appearance. But on Mercury, they're found in rock and often have bright interiors and halos. We've never seen anything quite like this on a rocky surface, he says. If you could stand in one of these sleepy hollows on Mercury's surface, you'd find yourself like Ichabod Crane in a quiet, still, haunting place with a jet-black sky above your head. There's essentially no atmosphere on Mercury, says Blewett, so the hollows could not have been carved by wind or rain. Other forces must be at work. As the planet closest to the Sun, Mercury is exposed to fierce heat and extreme space weather. Blewett believes these factors may play a role. A key clue, he says, is that many of the hollows are associated with central mounds or mountains inside Mercury's impact craters. These so-called peak rings are thought to be made of material forced up from the depths by the impact that formed the crater. Excavated material could be unstable when it finds itself suddenly exposed at Mercury's surface. Certain minerals, for example those that contain sulfur and other volatiles, would be easily vaporized by the onslaught of heat, solar wind, and micrometeoroids that Mercury experiences on a daily basis. Messenger has found Mercury unexpectedly rich in sulfur, explains Blewett. Perhaps the sulfur is vaporizing, leaving just the other minerals, and therefore weakening the rock and making it spongier. Then the rock would crumble and erode more readily, forming these depressions. More data from Messenger and further study by the mission's science team could reveal the answer. Meanwhile, Blewett wonders, what other surprises does Mercury hold? The sleepy hollows of the innermost planet may be just the beginning. For more of the mysteries of Mercury and other worlds, visit science.nasa.gov.